So this is our lab experiments. And we all know that all these three experiments are there. So today we try to complete the signal generation, and we will move on for FIR filter. Okay, in FIR filter, we are supposed to see low pass, high pass, band pass, and band elimination. And in IAR filter, we will go with two approximation, Butterworth and Chebyshев, with low pass filter only. Okay, so I think we all completed this embedded experiments. So I think you have done with the two softwares, Kale and Proteus. So for Kale, to develop and to check the register values and memory values and all. So normal arithmetic and logical experiments you have done. And in Proteus, how you have done? In Proteus, we have connected the hardware setup where how the simulation wants to do. We have connected all the hardware elements, and then we convert into hex file, and then we run the program. Okay, now the third software is going to be implemented is MATLAB. I think ma'am have shared the MATLAB with you. So now we will move on to the unit step. Okay, I will share the MATLAB. Yeah, I think this MATLAB is not a new one for you. Already you have seen about the MATLAB, and you have done the experiments in power system lab. But anyway, I will tell you about this. Okay, so here, students, can you able to view? Can you able to view the MATLAB screen? Can you able to view the MATLAB screen? Yes, ma'am. Okay, so file. Think you all know blank M file. I think the version is there. It's a very old version, 2009. I'm sharing to you. Some of them, when you look with 2000, I think ma'am shared 2015 version. So here, I think you people have installed this version or some other version. You have installed this version or some other version. Yes, tell me, ma. You have installed this version or some other version. Ma'am shared 2009. Yeah, thank you. Thank you. Same version, ma'am. Okay, okay, okay. Okay. So students, I think ma'am have explained all the commands to you. But one thing you understand, because remembering and hearing, we can't able to do. So when you go with that, I have opened blank M file, and you all know I have to save with the file name with extension of um, .m. Okay, M files. So save with that. Once you save, automatically it will save it in the path. You all understand help. Help is the command. We can know how the keywords we want to know about that. So you just help product help. I think while I'm sharing, it won't do. Okay, one thing I will do, I will share whenever I am sharing my screen. That option I will choose and come, because screen. Okay. Okay. Yeah. Now I think when I open help, can you able to see? When I'm opening the help, I think you can able to see two tabs in your screen. Yes or no? Yes, ma'am. Thank you. Because I have shared the screen. Wherever I move, automatically it will be visible. Okay. So you all understand that figure. What is the use of the figure command? When you click on that, I think you people were well known about that. It create a figure graphic objects. Okay. So while we are giving figure, it mainly to create the figure graphic object. So if I give figure automatically, I think automatically it will display. And similarly stem, if I search them, it will plot the discrete sequence data. So I think you have any doubt on this, you may check. So you see just the stem have this much of syntax is there. Stem y alone I can give, stem x comma y is given. So you see n is my x axis and x is my y axis. So that is also I can give. Okay. So can you able to view that MATLAB help screen now? Am I correct? If you can't view, kindly tell me. Okay. And X label and Y label, whatever I'm giving, that will be there. And title also there. If I give unit response step sequence, automatically it will give. Okay. Now, and you all know that N will be the number, total number of sequence. And sorry, ma'am, sorry. Okay. N will be the total number of sequence and small n will be the discrete sequence. Okay. And next you will see once. What is the use of once command? Okay. You just see it create array of all ones. So whatever I am giving, my array value will be 1. That means my discrete value 1 to 25 now. Once I execute, you will understand well. So I'm just executing. Can you able to view the MATLAB screen output screen, ma? Yeah. Yes, ma'am. Okay. I think now you don't want to have a problem. Enter the sequence. So I'm giving 25. So once I give 25, you just see, you can see that automatically my output will be there. Okay. So we have created from n colon n equal to small 0 colon 1 colon n minus 1. So every time there it will be there. So what is the command I give now? Once 1 comma n. That means for each discrete value, my value should be 1. That is unit impulse. Unit means we all know very well. Definitely I will have the value for 1 for discrete sequence. So X label, Y label will be there. Okay, and even you can give a title. That is, I will tell you at the last. So you have any doubt on this? Okay, I will complete. Oh, I gave stop share. Oh my God. Okay. So now this will be that you have to take the snapshot and you have to attach. Okay, now I will close this. I think ma'am taught exponential, sine, cosine and all. Okay, I will tell you the impulse signal. Okay, so you all in see how you have studied double slash or slash asterisk. So similar way, if I put percentage, then automatically this particular line will not be executed. That particular line will not be executed. Okay, okay. I think what is the difference? Generation of signal is very easiest one. So figure we have seen for to create the graphical image, and stem is used to create x comma y value. And that is mainly for creating the discrete. Okay, and what is the one more difference here now? Okay, I think this command we are supposed to learn. So every time you don't know any commands in MATLAB, it is easy for you. You can search it in help, then automatically you will see that. Okay, so you just see you know, identity matrix. So in that identity matrix, we all know that identity matrix, you know, ones on the diagonal and zeros elsewhere. So we will see that 1 0 0 1. So that is the identity matrix. So here what they were saying now, okay, I will, this is my identity matrix. Okay, okay. So here n by n identity matrix. So here we cover so many commands were there. I comma n, I comma m comma n. So one means at what the value of one only, the value will be one. So I think while we are executing, we can say that how it is executing there. So same 25 I'm giving. So you just see that all the values, it becomes 0. At that 0 only, the value will be 1. That is impulse. Short impulse, it will be at particular value only, the value will be 1. The remaining value, it will be 0. So impulse is a short impulse response. Okay. Okay. Next, we go with the next MATLAB program. Very simple RAM signal. Okay. Actually, in this RAM signal, they didn't go with any other commands. Okay. You just see a ramp and exponentials or a similar way. But what is the command I gave for ramp here, ma? Can anyone put it in chat? Actually, we have seen 3 programs. One is unit signal, and another one is impulse response, and another one is RAM signal. In unit signal, we have seen we have used once command. Okay, so we have seen for all the discrete value, the value will be 1. And while we are moving with the next one is impulse. So there we use the command I. Okay, then here what is the command we have used to do for again same impulse response? No, it is a RAM sequence. Okay. Can tell anyone what is the command we have used or what is the expression we have used to different from other one? You are in final year, so you won't speak. Good logic. But first year people, while they were saying, ask them to unmute, and they were people want to clear the doubt. But here we gave the options, but you people are not giving any answers. Okay, anyway, tell me the answer. What is the difference in syntax for previous 2 experiment and this experiment to generate the RAM sequence? What is the syntax I have used? Yeah, tell me, ma. RAM sequence means what? It's just how you will get it RAM sequence. Okay, this is the way. It's not a exponential. Exponential, we use the x equal to n cap and all, power n cap and all. This is the RAM signal we are going to generate. So what command I have used here? Can anyone tell? What command or what expression have been used? X equal to n colon. Very simple. If my x value is 1, sorry, my n value is 1, my x value is 1. My x value is 2, sorry, here n and here x. So I don't want to confuse. Okay. My x value is 2, sorry, n value is 2, x value is 2. This is 3 and this is 3. This is 4 and this is 4. And this is 5, this is 5. The similar way, very simple command we used, x equal to n colon. Okay, so now I will clear all drawings. So you run the program. So very simple. If I give the sequences 50, then automatically you can see that it will increase. So I can change my sequence. Is clear? Okay. Can anyone share these outputs that you people are doing parallelly? Almost signal generation, 6 signals were there. Kripa Nandiniya, Kirtana Priya. Yeah. Okay. Change the heading. Actually, in the program itself, we gave impulse sequence. Actually, it is a RAM sequence. Okay, ma. You save and run, automatically will. Yeah. you get the RAM sequence. So you all understand here. Here you people have how we will identify the difference between this is done by you and other experiment. Did you do anything? Impulse. This is which version, ma? Kirtana Priya. Or who is sharing? Kripanandiniya. Sa Kirtana Priya. Kirtana Priya.
Yes, ma'am.
Which version is it is, ma?
I'm using an online.
You are doing in? Oh, you are doing in online, ah. matlab.mathworks.com. You have created you now only you are installing, ah. Kirtana?
Yes, ma'am.
Actually 2021 you didn't install in your system, ah.
No, ma'am.
This is the first time you are doing.
Yes,
This is
ma'am.
the first time you are installing. Am I correct? Yeah, in your class we gave this way, but most of them were said that in power system lab you are have been used to the 2020 version. That's why we move on to the older version, but still that I think who have used the old version, they were comfortable with that. Okay, so yeah, so here in RAM sequence you gave now, so you type your name and roll number in title, yeah, title. You just put your name and roll number. You give title RAM sequence. Yeah, put. So students, while you're uploading, this is the only difference that you people are doing the lab in your home. You are supposed to put your roll number followed by your name. This is not only for this particular output. All the MATLAB outputs, you are supposed to put like this. Then only the marks will be given for the record. Are you clear or not? Because we need some difference between you and others, that actually mm, yeah. So then you crop and save it. I will share you where you have to put your MATLAB outputs at last. So for all the experiments, my kind request is you are supposed to give the title of the experiment followed by your register name and name. Then only we can understand. I think for all the experiment, you can give the title and you can do it. Okay. Yeah. Thank you, ma. So help you will understand that here we have used only the three commands majorly. One is stem n comma x, that is mainly to get your discrete value, and another one is figure value, and then another command is that is depends on the value. For example, unit step na ones comma n, impulse na I, and then RAM sequence na x equal to n, and then when you go with sine omega and cos omega, Vm into cos omega t and sin Vm into sin omega t, we did, and the next command we gave is x equal to Vm dot n cap. That experiment we gave. Okay, but while you are giving that power value, it should be always less than 1. If it is sorry, if you give that Vm value, it should be always less than 1. If you give more than 1, you won't get the curve correctly. And one more thing, while you are doing your experiment, your step sequence should be equal to your roll number. For example, uh, Kirtana Priya roll number is 19 now. She have to give the step sequence value 19. Then one more doubt will be asked, 1 to 10 what we have to do? 1 to 10 multiply into 10. For example, 1 na 10, 2 na 20, 3 na 30, 4 na 40. the way you have to give, and you all know that that output only you are supposed to upload, and you all your project will be based on the MATLAB only. So kindly install the MATLAB in your system. So till your completion of final year, but it will makes the system somewhat slow. But the version ma'am gave for you will be the space occupied will be very less comparing with others. Okay, is clear, ma? Are you clear? I think I will share you that MATLAB programs. You just see this. We will put up in your uh, LMS. So you have to enter your name and you enter your register number. Everything is given in output itself. You have to paste your output here. Are you clear? And enter the number of sequence. I told you your roll number will be your sequence. Okay. For this experiments, you are supposed to follow this. Okay. All 6 signals are generated. Okay. The next one is FIR filter. Okay. I think I will tell you that experiment. Then we will go with the how it is working and all. So here FIR full form is FIR filter, finite impulse response filter. Okay, so far you have studied all the passive filters in your LIC and all. While we move on to DSP, we have studied about all digital filters. So using delays, multipliers, adders, they have designed this filter. And while we are moving with this finite impulse response filter, we will do all 4 filters and all we will do it. But the windowing methods, we will have finite impulse response. So we will put one window to get the output. There we have followed so many windows here: Hamming window, Hanning window, triangular window, boxcar window, rectangular window, and all we have used. But I want very specific for this filter. You are supposed to use this windowing technique. That is not required for you. Okay, and one thing you do here, we will share with this. So omega c is nothing but your cutoff frequency, and n will be the order of the filter, and alpha and epsilon are the constant of the filters. That values are fixed. You see, alpha is n minus 1 by t, and epsilon is 0.001. And HT, desired frequency response is this. And windowing function, omega h equal to Hamming of n. Hamming of n means it's nothing but a windowing function they given. You just see HT value, desired frequency response. I think here desired frequency response we are given, but in FIR filter, what you will design, ma'am? Did you remember? Finally, what you will decide? The question is so simple, you won't answer. You will design the transfer function. Am I clear? So you will design the transfer function that will be in a time domain, but here we are going to get it in frequency domain. So that's why we are converting, we all know that S equal to j omega. So S equal to j omega, we will convert the transfer function into frequency response. Okay, because my transfer function will be in the S domain, so we will convert into frequency response. So we have used omega h. We have used omega h. Okay, in that omega h, the windowing function. So what kind of windowing function I am using? Here, Hamming window I am using. Okay, and then Hn. Hn will be symmetric impulse response. You have seen that. I think I will clear this. So you just see Hn equal to this is very important while you are typing, because or else it will throw the error message into asterisk omega h dash. Okay, so you all know this is will be symmetric impulse response, and this will be frequency response. Okay, and omega h will be your windowing function. Okay, so you all know the dash in MATLAB. What is the meaning of, if I put a dash, what is the meaning of that? You have done power system lab. A dash now, what is the meaning, ma? A dash is nothing but I will get the transpose. For example, if we simply I give A dash, it is a complex conjugate. If, for example, if my A value is 1 plus 2j, and you all know that complex conjugate now, my A dash value will be 1 minus 2j. Okay. But when I give dot dash, that's very important. That why we are doing such a function now, the column row transpose will be there, then only you will can able to multiply. We all know well, I can multiply 3 cross 2 into, okay, I think it's not visible, the color I will change. 3 cross 2 into 2 cross 3 is possible, because the matrix, while I'm doing the multiplication, my column of first matrix and the row of second matrix has to be matched. So for that, we are giving the transpose and we are multiplying, and then, okay, inverse, I guess. Okay. So here, okay, so here while we see omega value, because what is the cutoff frequency? Low pass filter. Low pass filter means what? I will get my filter like this. Am I correct or not? I will get it like this. And what is the cutoff frequency? I told you 0.5. And what is the value? 0, 1. Okay, this is my cutoff frequency, and this is my amplitude in decibel. Okay, that is also normalized, 0 to 1. Okay, so here my cutoff frequency I gave 0.5 into pi, and here my omega value is 0.1 pi. So while I'm giving that, whenever I'm putting 0.5 by pi, then while we convert into the normalization of the filter, the pi get cancelled. So I will get only 0.5. So whatever value I am giving, that is my cutoff frequency. If I give 0.7, 0.7 is my cutoff frequency. Okay, and here we will see the two commands in um, in our MATLAB command, mainly to plot the frequency response of the filter, and plot will give the plot. Okay, we will see with the, I will stop share and I will share the screen. Okay, so I think low pass filter LPF are already done. So you all seen this. While you are going and checking, you just put product command FR. Okay, frequency response of your filter. Are you clear? I think while you go with this frequency response, we will obtain the transfer function, and from the transfer function, finding the coefficients. Did you remember? Through that also it will do the plot, but we all know here we have converted the transfer function into symmetric impulse response, frequency response, and from the frequency response we multiplied the frequency response with the windowing function, we got the impulse response, and from the impulse response we are going to plot the frequency response of the filter. So F for EQZ, it's mainly for to get the frequency response of your filter. So you have seen that there are so many commands have been used, HA, HA, N, HD, N and all. But here we what we put now, N is the order of the filter. But here instead of N, sorry, instead of n I have put omega, because hn we will plot it in magnitude in decibel in y-axis, and frequency in x-axis, and my value should be rounded off to 1. I told you my numerator, sorry, my x-axis as well as y-axis both will be in one only, so it will be there. Okay, so F for EQZ is frequency response of your filter. Then plot, you go with plot. Okay, So plot is nothing but it's what you did figure. Okay, so similar way, my plot is nothing but a two-dimensional plot. So x value and y value we will put it. So stem is mainly for discrete value we will put. So plot omega comma pi. I think they will give you x1 y1. Okay, x-axis is omega pi by pi. I told you that here I'm not get the value, all my value will be divided by pi. So you have seen here 0.8 into pi na divided by pi, 0.8 will be there. So we normalized from 0 to 1. Okay, and absolute of h, that will be in decibel. Okay, or r is in which color na? Red color. I can change the color also. I think so you will see that how we have to mark. Actually, I give dash na, the entire line will be there. So you can use a kind of width comma. So you will see this, how they were specifying the command double dash. I can put it. Okay, and for R for red, B for blue and all also we can type. And this is for continuous tracking. Okay, just you give plot x comma y, you will get continuously tracked. So this is the way plot, okay, with the red, and you can change your line width. But nowadays it's not needed to change all in x label and y label. We can change it in the diagram of the MATLAB itself. Okay, so I will run the program here. I didn't give any inputs and all. You just see, I can directly get my value. So if I put blue, sorry. Oh my God. Hmm. It is turned into figure. So instead of this asterisk, I told you now, we put it asterisk. So we can use various commands also to put, and I can change it that. Okay. For example, if we put, so you will get the dashes over here. So depending upon that line style, I told you we have an option to change it. So previously we put the title here. Okay, I think when you go and insert, tools will be there. So we can change, and we can do all this. If I give title, then automatically low pass filter, because there we have to give, because we used only stem command, and that low pass filter followed by your roll number, sorry, register number, followed by your name. And you want to change the line width also, you can able to change. Figure palette is there na, in view you go to figure palette. Then once you press the figure palette, automatically my page will be navigated to there. So there I can do all kind of changes. So once you that, I can change my background. So there you choose the figure palette in view now. This will be mainly, especially in your project and all you are supposed to do. So I can change my line width. Okay, I can change my colors, and I can mark how I have to plot the value, and I can change my x-axis and y-axis. You have seen x-axis and y-axis. It should be in which color, and the background also I can be edge color and all. I can change into red. So that is also background color. Background color we changed, and if you want to put light, mild, I think it's all in x-axis and y-axis. So this you can change the font also. Okay, so you color figure color, you can change it. You just see, once I change, it will become. So if I change white, it will become in white. So here everything we can, I have put that edge color. If I put what white, it become normal. So all this kind, I think related to that, you can do it very simply. You just then you can undock. You have option. You have undock option is there. Can you able to view? At the top, I have undock figure 1. So once it is undocked, it automatically will come here. So here the steps to be followed, what we have done. So listen, very simple. Um, we have to enter the cutoff frequency order linearized parameter. So cutoff frequency is nothing but we enter the value of omega c. We enter the value of omega c. Order of the filter, capital N. Linearized parameter, that is, I told you, two parameters we have used. One is epsilon. Okay, we use the command epsilon, and another one is what? Or you people are listening? Alpha. I have used epsilon and alpha. We all know the epsilon symbol is like this, and alpha symbol is like this. I think this is that mathematical expression for low pass filter. Okay, we are getting the frequency response of the filter, HT of n. Similarly, high pass filter also we have a separate expression. So sine omega c, small n we all know how we have to enter. It's a discrete value. So 0 colon 1 colon n minus 1. Okay, then we have to give all these inputs. Once I give, then we have to obtain the frequency response. Then we have to identify which windowing technique is there. So once I multiply that frequency response with windowing technique, I will get h of n. What is h of n? It is a symmetric impulse response. So once I get that symmetric impulse response, you can using frequency response command. Okay, for EQZ, that is, I will get both magnitude and phase response using the frequency function in the MATLAB. Then I will display the result using plot command. So this is a very simple method, and this is the algorithm we were following. Low pass filter, enter the cutoff frequency, order of the filter, filter parameters, then find out the mathematical expression. You are supposed to remember that, and then you have to multiply that mathematical expression, that is frequency response, with your windowing technique. You will get your symmetric impulse response. Then using a frequency command, you will get x versus y, that is a frequency versus my amplitude. And then you have to use the plot command, and there I am just doing the normalization omega pi pi. So my frequency value is also from 0 to 1, and my decibel is also 0 to 1. Okay, then we use the colors to plot, and that I told you, you can do it in program, or else you can put it over to the move on to the figure palette in view menu, and then it will automatically navigate it to your MATLAB screen. There you can use the figure palette commands to edit your vision, change the color, thickness, everything you can do it normally. Okay. Okay. So here, so we have used Hamming window now. So simply we will use boxcar. Okay, we will use boxcar. And one more thing, instead of 0.8, So question in examination, you have to know where you have to change and all. Okay, I will give 0.5. Even I change the order, it doesn't reflect that only the points will be changed. Hmm. You have seen this is my boxcar window. So previously it's not a harming window and it is a boxcar, and you have seen I have changed my cutoff frequency to 0.5. So that's why it get changed. Okay, so I think you have studied in 6th semester in DSP very well about all this windowing techniques and all. So you all understand the questions will not be a general question. In arithmetic and logical already you have seen, but when you go with MATLAB, we are supposed to use this windowing technique along with the cutoff frequency we will mention. So to that only you have to decide. Is clear? Did you anyone do ma? I will stop share. Will you share it your low pass filter screen with, yeah, Kripa Nandini has started. Kripa Nandini, I think it's not a 0 to 1. Have you seen? I think there is small change. Instead of sine pi, you put sine omega c here in 6th line. I think that which is given in your manual is wrong. Actually, there the formula is correct, but no, upper one. 6th line, sine omega c you put. Delete the pi. Sine of pi you have written, na? Here, this pi. Yeah, omega c. Omega c. Here you have written WC, not into you put asterisk. Yeah, now you run. Yeah, we all understand. It's a small mistake. Actually, everyone have to find out this. It's not pi. Actually, we have given in the there we have given correctly, but here you are supposed to do like this. Yeah. Oh, various lines and okay. Here also you can do with that. Yeah, good ma. So next we will go with high pass filter. I think almost the same procedure only we are going to follow, because band pass and band elimination only we have a difference in that. But when you go with high pass filter, there is not much difference here. Okay. Okay, so here they gave 0.5. So instead of 0.5, I'm giving 0.2. Okay, we all know that high pass filter, and they used which windowing technique? Na Hanning windowing technique. Okay, so many windowing functions are there. When you go to the product help, you just put windowing. Okay, you just type windowing. Actually, that is one of the very advantage of MATLAB, because the coding, if they asked, it is easy for you to find out. So you will see that in FIR filter design and all, they put various windowing techniques, windowing methods. You just see Hamming they were used. Okay, you all see here they just put the transfer function they identified. Windowing methods, while we are seeing that, hamming, hanning, boxcar, rectangular, triangular windowing functions we can use. Okay. Screen not visible. Oh my God. Okay, I will share. Now is it visible? Now can you able to wear? Yeah, I think. Okay, so this is multi-brand precision and all they gave you. With that, you all see normalized frequency. So the value is always from 0 to 1 only. Okay. And when you go with that, in our magnitude in decibel is also from 0 to 1, and it is a linear phase filters. So other value, while we are getting IAR filters and all, we have the value, but we will always normalized for that. So you have seen FV tools also there, filter visualization tools also there, but our thing is we will very particularly to get the value. So I'll just click on, so you just see our cutoff frequency get changed 0.25. So this is my attenuation band and this is my pass band, and my magnitude of decibel is also from 0 to 1, and my normalized frequency also 0 to 1. So we have put it normalized by putting 1 over here, my maximum value limited to 1, and by dividing omega by pi is here also, because my omega value is from 0 to pi, and whenever I divide the value, automatically what happen now, the value will become to 1. So for that we will getting this value from 0 to 1 in both x-axis as well as in the y-axis. Okay, I think shall we do it on the, so here I think this is the problem. Here you all people remove it and put omega. Okay, I think you make note of it. Don't put this value. So here my value is omega c, cutoff frequency. So remove the pi and put omega c, that alone. Okay. And this is about my high pass filter with Hamming window. When you go with band pass filter with Blackman window, you are supposed to enter two cutoff frequency. We all know the band pass having the limit of uh, first cutoff frequency and second cutoff frequency. So band pass, one value is 0.5, sorry, 0.25, and another one is 0.75. So I will get a two band of cutoff frequency between 0.25 to 0.75. And you all know this HD formula you have to definitely study. Okay, and you all know in DSP, I think whoever studied, they can understand how much difficult to get the FIR filter design and all. Because Butterworth and Chebyshев is also difficult, but we have the formula. But here I thought in my perception and saying FIR filter design is somewhat difficult to solve and to get the final transfer functions. But when you go with this, we easily get out our frequency response, and then we find out all this. Okay, so band rejection filter is also about that. Okay, so I think the band rejection, the cutoff frequency, actually we will get the curve in this way. So this is 0.25 and this is 0.75. So definitely in my frequency response, I have a two cutoff frequency sequence, omega c1 as well as omega c2. Okay, will anyone share the outputs? Will anyone, I think we will anyone share the output? Kirtana Priya. Sharma. Any one of you kindly share the screen, ma? Yeah, very good, ma. So you all understand that first cutoff frequency, order of the filter, filter constant, that is these two. Then n equal to discrete value 0 colon 1 colon n minus 1, and there I'm finding the frequency response of the filter. Then I'm finding I can use any window, just you change into Blackman instead of Hanning, put Blackman. Yeah, now you execute. Yeah, that's not much different, but when you enter into triangular window or rectangle window, you will see the difference. If you put boxcar will show much difference in other windowing function. Boxcar, car, car. Yeah, because what kind of no windowing technique the well changes, we all know for each windowing function we have a formulas over there to calculate the uh, response. So this is for that. Okay, and you can change the frequency also. So low pass filter and high pass filter we will see, and the explanation is given for band pass and band elimination. Okay, so today I am going to take the attendance because oh, I'm taking the classes for I think around 10 classes. No one is opening. I think we will see whether you can able to speak or not today. Okay.